tricking when I buy the things I like. Dollars dropping on my ass tonight. Everyone silent.
What's up, guys? My name is Hexagons Jr. I am the leader of Group 2 in Section Kilo. So for today's video, I am going to report the hexagon in nature. If you have ever wandered around in nature, you may have noticed how many geometric shapes there are in the world that absolutely not designed from humans. Patterns and geometry are everywhere. But nature seems to have a particular thing for the number 6. Beehives, rocks, marine skeletons, insect eyes. It could be a mathematical coincidence, or could there be some pattern beneath the pattern, and why nature arrived at this geometry? But what makes hexagon so special? Well, as it turns out, it really is all about math. A hexagon is a shape that best fills a plane with equal size units and leaves no wasted space. Hexagonal packing will also minimize the perimeter for a given area because of its 120 degrees angle. With this structure, the pull of surface tension in each direction is most mechanically stable, which is why even thought bees make their honeycombs with circular units. The end of the result, when the wax hardens into place, is hexagonal. I will give you an example of what I discussed, and we can test this with actual bubbles. 2 equal size bubbles, a flat intersection. 3 and we get all meeting 120 degrees. But when we add a fourth instead of a square intersection, the bubble will always rearrange themselves, so their intersection are 120 degrees, the same angles that define a hexagon. The video you're going to watch is my member answering the guide question about the golden ratio and the Fibonacci.
Hi everyone, my name is Rene Lunhayan, BS Criminology from Section Kilo. Our topic for today is all about the golden ratio. So now, question number 1. What math concepts is fully discussed in your assignment video? Golden ratio is also known as the golden section, golden mathematics, the irrational number, 1 plus the square root of 5, which is approximately equal to 1618. It is a ratio of the line segment. Question number 2. What about this concept? Cite a few more real words, causes, or example. We know that golden ratio, discovered by the Pythagoreans, the ratio of the lights of any diagonal of a rectangle pentagon to the light of inside is equal to the golden number. Question number 3. What are the insights about these mathematical truths or certain? The golden ratio is a great example in mathematics to our daily life.
What math concept is fully discussed on your assigned video? The math concept to discuss on my assigned video is the golden ratio and Fibonacci in music. The golden ratio is the irrational number pi, and like pi, it doesn't end. Well, as the sequence goes higher, get closer and closer to 1.618 and so on. Sum of this golden ratio and the Fibonacci sequence in the third movement has a arithmetic pattern. What is about this concept? Cites few more real-world cases or examples that would show the concept. The golden ratio is used as the interval between higher and modular, such as that the resulting timbre is in harmonic cloud of golden ratio related partials. The golden ratio can be found throughout violin. Golden ratio that comes from the Fibonacci sequence is also used for saxophone, mouthpieces, in speaker wires, and even in the acoustic design, music strings of some cathedrals. And some example of the golden ratio is the flowers or the sunflowers that form as in pi. What are your insights about this mathematical truth or certain test? Truth because the golden ratio and Fibonacci was exist hexagon in our nature, and since the beginning of time, the mathematical is we see it everywhere and the world around us.
Good day everyone, my name is Patrick Arisa Perez from Section Kilo. The Golden Ratio and Fibonacci Sequence. What is Golden Ratio? Is the golden ratio of line segment cut into the two faces of different lengths such that the ratio of the whole segments to that of the longer segments is equal to the ratio of two longer segments, shorter segments. Main result of example the golden ratio. For example, the measurement from the navel to the floor and the top head to the navel is golden ratio. Fibonacci sequence. The Fibonacci sequence is a set numbers that start with a 1 or a 0 followed by 1 proceeds based on the rule each number called Fibonacci numbers is equal to the sum of the preceding two numbers. An example of Fibonacci sequence, the number of petals in a flower consecutive follows of Fibonacci sequence. Famous examples include the lily, which has the 3 petals, buttercup, which have 5, at left person. And how Fibonacci sequence used today. The Fibonacci sequence, number sequence, they are most often applied within computers search algorithm that can also accurately stem leaves spacing of the tree. Ancient Greek architecture used the golden ratio of determine placing dimensional relationship between the building and height and size protocol and even the position of columns supporting structure. The golden ratio and Fibonacci sequence is a great mathematics that we can encounter without knowing. Bye bye.
Hello everyone, this is Junami Bidding Show. So for today's video, I will answer the following 3 questions that is assigned to us as a member. So the first question is, what math concept is fully discussed on your assigned video? So the math concept that is fully discussed to our group is the hexagons in nature. The second question is, what is about this concept? Cite few real world or cases or example that would show the concept. So we already know that hexagon has a 6 sides and 6 angles. We can see the hexagon everywhere. Their toys, things, appliances, foods, and also to our nature. When it comes to our nature, hexagon is rarely to find, but there are some part of the nature that hexagon exists. Like for example, the common example of this is the beehives. A beehive is the perfect example of a hexagon because it has 6 sides and 6 angles. The second example is the insect's eye. We can't define what is the shape of the eye of the insect unless we're going to use a microscope to see it clearly. When we use a microscope, that is the time that we can identify the shape of the eye of the insect, and it is the hexagon. The third example is the basalt column. Basalt column has also a 6 sides and 6 angles. So those three examples are some example of hexagon in nature. The third question is, what are your insight of this mathematical truth or entities? So for me, my insight about this mathematical concept is truth, because hexagon really exists in our nature. That's all. Thank you. Bye-bye.
The concept that fully discussed in our assigned video is about using the golden ratio, also known as pi. This concept is all about golden ratio, or also known as pi. Example of this is 1.618033987. We don't need to tell the whole number by simplify or just calling it pi. Another example, 0.112.358. If we put the number in rectangular, it can make golden spiral. My insight for mathematical truth is how to put some number in golden spiral, how to use pi in our modern technology.
So guys, I explained about what is the Fibonacci sequence and the golden ratio. Fibonacci sequence is one of the most famous formulas in mathematics. Each number in the sequence is the sum of the two numbers that precede it. So the sequence goes 0, 1, 1, 2, 3, then 5, 8, 13, 24, 25, and so on. It's been called nature's secret code and nature's universal rule. Just take a look at the pattern it creates and you can instantly recognize how this sequence works in nature, like an underlining universal grid. And what is the golden ratio? The golden ratio is a design concept based on using the Fibonacci sequence to create visually appealing proportion in art, architecture, and graphic design. The proportion, size, and placement of one element compared to another creates a sense of harmony that our subconscious mind is attracted to. Then number 2, what is about this concept? Cite more real-world cases or example that would show the concept. A perfect example that is the Nautilus shell, whose chamber adhere to the Fibonacci sequence logarithmic spiral almost perfectly. This famous pattern shows up everywhere in nature, including flowers, pine cones, hurricanes, and even huge spiral galaxies in space. But the Fibonacci sequence doesn't just stop at nature. In graphic design, we refer to it as the golden ratio. It can be applied to everything from logo design, print design, and website design. And number 3, what is your insight about this mathematical truth or certainties? As designer, there are no rules when it comes to creating an aesthetic of or an effective design for a project. Sometimes we find that golden ratio works perfectly in application, while other times we come up with a great idea and doesn't necessarily follow the rules. There is an ongoing debate among graphic designers, mathematicians, and scientists about whether the golden ratio in relation to design is a myth. But there is plenty of evidence, not only in nature but in creative design that proves the ratio to be a solid tool for us designer. It can be a helpful when creating a grid for a layout, finding the perfect cropping for a photo, or figuring or out sizes per type hierarchies when featuring content. Just to name a few, overall, it's an interesting way to look at great design through a mathematical lens, and we think it's fascinating to identify where and how it is used in the world around us.
Hi everyone, my name is Hans Adrian Calvo from Section Kilo. Our topic for today is about the golden ratio. Question number 1. What math concept is fully discussed on your assigned video? The golden ratio and the Fibonacci sequence. Question number 2. What is about this concept? A search of numbers has inspired the world around us. The golden ratio is the irrational numbers pi and a pi it doesn't end. Some people say that the golden ratio and the Fibonacci sequences are evident in music for strings. For example, percussion and celesta, Hungarian composer Béla Bartók, the opening xylophone solo movement has a rhythmic pattern following the Fibonacci sequence is significant because of the so-called golden ratio. Question number 3. What are your insight about the mathematical truth or certainties? The golden ratio and the Fibonacci is a great example of mathematics that we can encounter almost daily without even knowing them. Thank you.
First question. What math concept is fully discussed in your assigned video? The concept that fully discussed in our assigned video is this number that can be seen almost everywhere you look. This called a golden ratio, and the one called Fibonacci sequence. Second question is, what is about this concept? Cite few more real-world cases or examples that would show the concept. The golden ratio is the irrational number pi. We see it everywhere in the world around us. But did we know that we can also hear it in our favorite song according to the sound field? From the notes and chords and to the phrasing and dynamics, it's also a golden ratio. Many people believe this is not a coincidence but the golden ratio in action. Third question. What are your insights about this mathematical truth or certainties? My insight about this is truth because it exists in our world. Everywhere, number is around us. We just don't know that this golden ratio is we usually use it a way that we don't know that we already use it.
Good day, everyone. I am Julina Moreno Lagulo from Section Kilo, Group 2. The golden ratio and Fibonacci sequence. A series of numbers that inspire the world around us. This number can be seen almost anywhere. It's called the golden ratio. Golden ratio is the irrational number pi. Unlike a pi, it doesn't end. Some say that the golden ratio and Fibonacci sequence are evident in music for strings. For example, the percussion and celesta by Hungarian composer Béla Bartók. The opening xylophone solo movement as a rhythmic pattern, following the Fibonacci sequence, going from 1, 2, 3, 4, 5, 6, 8, and then back down 5, 3, 2, 1. The Fibonacci sequence is significant because of the so-called golden ratio of 1.618 or its inverse 0.618. The golden ratio doesn't account for every structure or pattern in the universe. It's certainly a major player. Example, flower petals. The number of petals in a flower consistently follows the Fibonacci sequence Examples include the lily, which is 3 petals, buttercup, which has 5, the daisies, 34, and so on. The golden ratio and Fibonacci sequence is a great example of mathematics that we encounter almost daily without knowing it.
Good day, sir. I am Jericho Emolis from Section Kilo. Number 1. What concept is discussed in your assigned video? The concept discussed in the video assigned to us about the golden ratio and Fibonacci in music. Number 2 is the concept all about cite few more real-world example that is relevant to the concept. What I have learned from the video is the golden ratio is the one of most enigmatic and beautiful number ratios in mathematics. The golden ratio may be found practically everywhere, although not everyone is aware of it. The golden ratio is a unique integer with a value of 1.681. The ratio was expressed using the Greek sign by an American mathematician named Mark Barr. The golden rectangle is another term of golden ratio. You can remove a square from a golden rectangle and a smaller version of the same rectangle will remain. If you keep doing this, eventually a spiral will develop. In mathematics, a golden rectangle is a very important and unusual form. The golden rectangle is another term of the golden ratio. Artists will be sure to use the ratio will design structure, sculpture, or paintings. The golden ratio has numerous components and unique features, and the following easy will discuss the ratio occurrences around the world as well as its relationships, application, and construction. Some another example are flower petals, particular the lily, daisy, and others. Another is the seed head. Fibonacci progress can also be found in a flower head. Seeds are typically formed in the center and subsequently travel outward hope to occupy all available space. Sunflower are wonderful example of swirling patterns. The Fibonacci sequence can also be seen the formation and split the three branches and primary trunk will continue expand until the produce a branch which will result in the formation of the growth points. Another example is the golden rectangle special nature features. This shape a rectangle with a side AB and equal to the golden mean can result in a nesting process that can be repeated indefinitely and take the shape of spiral. Is known as the logarithmic spiral and it can be seen abundance in nature. Number 3, what are your insights about this mathematical concept? The preceding explanation, example, and demonstration demonstrate how mathematics and art are inextricably linked. Not only can art reveal mathematical forms, but nature and universe do as well. Mathematics is not an abstract subject, but its consequences can be observed all around us and all living things. I could see that mathematics is indeed an art form in and of itself with beautiful application. As a result, we arrived to the conclusion that mathematics and art were inextricably linked. We must understand mathematics and art as well as their irrefutable relationship and cooperation in order to comprehend, comprehend and enjoy the world we live in. Thank you.
Hi, I am Trishan Oliedo from Group 2, and I am here to answer the questions. What math concept is fully discussed in your assigned video? What is about this concept, and cite real-world cases or example that would show the concept? And lastly, what are your insights about this mathematical truth or certainties? So let's answer first the question, what math concept is fully discussed in your assigned video? So the concept discussed in the video is the Fibonacci sequence and the golden ratio. The next question is what is about this concept, and cite real-world cases or example that would show the concept. It is discussed that Fibonacci sequence is a set of numbers that starts with 0, 1, 1, 2, and then the following numbers is the sum of the two preceding terms. It is also discussed in the video how Fibonacci sequence and golden ratio used and applied in music. And also, if the sequence of Fibonacci goes higher, the ratio between the number gets closer and closer to 1.618 or the phi. Some of the situations where we can observe Fibonacci sequence is in hurricanes, in spiral galaxies, and even our bodies exhibit proportions that are consistent with Fibonacci numbers. It is also used in creating music by many late musicians. The last question is, what are your insights about this mathematical truth or certainties? Well, at first, I didn't know that Fibonacci sequence and golden ratio can also be used in creating music. As I have finished watching the video, I have realized that Fibonacci sequence can be seen in many situations like hurricanes and also in our phases. And for me, Fibonacci sequence and golden ratio are two of the interesting topics in mathematics.
Good day, sir. My name is Leah Joy Omaturan from Section Kilo. Today, I will answer the 3 guide questions that assigned to us. Number 1. What math concept is fully discussed in your assigned video? The math concept that fully discussed in our video is about the golden ratio and the Fibonacci in music. What is about this concept? Cite few more real-world cases or examples that would show the concept. The concept is all about the golden ratio and Fibonacci in music. Golden ratio is a design concept based on using the Fibonacci sequence to create visually appealing proportions in art, architecture, and graphic design. Example of golden ratio is flower petals. The number of petals in a flower consistently follows the Fibonacci sequence. Fibonacci in music plays a big part in Western harmony and musical scales because an octave on the piano consists of 13 notes. 8 are white keys and 5 are black keys. Example of Fibonacci in music is Genesis' Brave Song, 1st of 5th, which contains solos of 55, 34, 13 bars entirely based on golden numbers. What are your insights about these mathematical truths or certainties? My insight about this mathematical truth is that golden ratio is truly unique in its mathematical properties and pervasive in its appearance throughout nature, and also it is a unique mathematical relationship.